Alright guys, we're still talking about rational equations. This is page 2 of your guided notes. At this point, you've got to start watching for denominators. If you remember in the last problem that we looked at, we got 0 and I said it couldn't work because it made the denominator equal 0. So I kind of want to refresh your memory on this. Alright, if you recall from previous math classes, anytime you have 0 divided by any number, you're going to get 0. Okay? And if you have 5 or any number divided by 0, you get undefined. Okay? So that's what we have to worry about, the undefined part. If something is undefined, that means it won't work. I mean, it doesn't exist. Okay, so it's just undefined at 0. If you remember talking about slope way back when in a different math class, you couldn't have 0 in all of your classes from here on out. That's the way it will be. Alright, so we have a certain thing that we use to talk about this. So division by 0 is not possible. So any solution we find that would make the denominator equal to 0 will not be a solution. Okay, so that doesn't mean you solved it wrong. It just means when you plug it in or you look at the denominator, it can't work. So we call this an extraneous solution. Okay, so what is an extraneous solution? An extraneous solution is a solution that you get from the original problem that when you plug it back in, it doesn't work. Okay? So, you may get a wrong solution because you solved the problem wrong, but you may get everything exactly right and still get a solution that won't work, and that would be called an extraneous solution. Alright, for example, identify whether each solution is a solution, not a solution, or extraneous. Okay, so we're going to check each of these numbers in this problem here just to see if it's a solution, not a solution, or if it's an extraneous solution. Alright, so how am I going to do that? I'm simply going to substitute the numbers in. So if I put a 3 in here, 3 plus 3 is 6. So I'm just going to write it down right here. 4 over 6. Does that equal 2 times 2 times 3 is 6, so does 2 over 6. Does 4 6 equal 2 sixths? No. So this one is just not a solution. Okay, that one doesn't work. Those two are not equal. Alright, so the next one is 1. So if we have 4, and we put in 1 plus 3, 1 plus 3 is 4. Does that equal 2 over 2 times 1 is 2. So does 4 over 4 equal 2 times 2 over 2? Yes, that works. And if you plug a 1 in here and here, it does not make it 0. It works out. So this one is a solution. Okay? Alright. The next one is 0. So we have 4 over 0 plus 3. 0 plus 3 is 3. And then we have 2 over 2 times 0. 2 over 2 times 0. 2 times 0 is 0. Okay? So this one has a 0 in the denominator. So this one is undefined. That one would be extraneous. It's not a solution. It would be extraneous. Alright, let's look at -1. 4 over -1 plus 3. -1 plus 3 is 2. Does that equal 2 over 2 times -1? 2 times -1 is -2. Okay? So 4 over 2 is 2. Does 2 equal -1? No, that does not work. Okay. Since that does not work, I'm going to put a slash through that instead of an X there. Then that would be not a solution. Okay? And then I'm going to check one more here. All right, -3. So I have 4 over -3 plus 3 equals 2 over 2 times -3. -3 plus 3 is 0. Because that equals 0, this is extraneous. Okay, you can't have a 0 in the denominator. Okay? Alright, so I hope that helps a little bit on looking at those. So let's see how to solve a rational equation and then check the solutions as we go. Alright, so this one has x plus 1, x minus 1, x squared minus 1. If you remember our steps, we had to factor if possible, then find a least common denominator, multiply by the denominator, and then solve. So this I know is a difference of squares. Okay, you will see this a lot in state testing and stuff. They like to use a difference of squares, even the ACT, because it's easy to factor. A difference of squares is the same binomial, different sign in the middle. Okay, so I'm just going to mark through that because we just rewrote x squared minus 1 as these two factors. Alright, so now I'm going to have a very lengthy denominator here. So on the front end, I'm going to have 3 over x plus 1. I need an x minus 1 here. So I'm going to multiply the top and bottom by x minus 1. So they have the same denominator. Okay? And then I'm going to have 1 over, I have x minus 1. And this one needs an x plus 1. Okay? So I'm going to add an x plus 1 and an x plus 1. So now they have the same denominator. Again, anything divided by itself is 1. So when I add that, I'm not really changing the problem. I'm just kind of manipulating it to make it do what I want. Alright, now this one already has both x plus 1 and x minus 1. So it already has the common denominator. We don't have to change it at all. Okay? Now, once we get a common denominator, we can multiply by the denominator, which is x plus 1 and x minus 1. And I'm just going to put d for denominator over here because it's going to be the same thing. And that means all of that will reduce, cancel, go away. Alright, now distribute. So I've got 3x minus 3 is equal to 1 times x is x, and 1, and then bring down my -2. So see, once we get our common denominator and we multiply by the denominator, it gets rid of the fraction, and it looks so much simpler already. So then it's just simply solving an equation. So let's get our x on one side. So I'm going to have 3x minus x is 2x. I've got minus 3, and then I've got plus 1 and -2 on the same side, so I can combine those and get -1. Now add 3. 2x equals -1 plus 3 is 2. Divide by 2. X is 1. Okay? So when I solve this, I get x is 1. Now I come back up here and I look. Here's my denominator. Okay? So when I look at the denominator, I got to check it. Make sure it will work. If I plug a 1 in here, 1 plus 1 is 1. That's 2. So if I plug it in the second one, 1 minus 1 is 0. Uh-oh, we can't have 0. If we get 0 in the denominator, remember it's an extraneous solution. So this is actually not a solution. It's an extraneous solution. So this one would have no solution. Okay? So, even though we did everything right, worked it out, solved it, got a solution, when you plug it in, if it doesn't work, it's an extraneous solution. All right, let's look at another example. Whoops. I'm going to move it up so I have a little bit more to write. These take up a lot of space. All right, so this one right here has x plus 3, x minus 1, x squared plus 2x minus 3. The first thing I'm going to do is try to factor this side here, so I can say x times x, what multiplies to give me 3, and adds to give me positive 2. So I need plus 2 and minus 1. Oh, and we get lucky because now those denominators are what we have on the other side. All right, so I'm going to bring this down. My first term here has a denominator of x plus 3. So I already have x plus 3 here. But I need an x minus 1. So I'm going to put x minus 1. And then I have minus 1 over, and this one has x minus 1. So I need an x plus 3 for this one. All right, and then I have equals. And I'm going to leave the denominator alone. The numerator. As you can see, we don't think much about the numerator until we get a common denominator, our least common denominator, and then multiply and get rid of our fraction. Then we start worrying about what's on top. So, x plus 3, x minus 1, x minus 1, x plus 3, x minus 1, x plus 3. Now I have a common denominator. It's an equation. Whatever I do to one side, I do to the other side. So I'm going to multiply both sides by the denominator. Again, that's like over 1. So that means that's on top. It cancels out with what's on bottom. On top cancels with what's on bottom. So that is very nice because then you just have to distribute and bring down your numerator. So I've got 2x. 2 times negative 1 is negative 2. Again, I have a negative here. I'm going to bring that down and put parentheses. It's hard not to lose that negative, so I'm going to bring it down and so I don't lose it. And then 1 times x is just x. 1 times 3 is 3. Equals negative x squared minus 3x. Because see, when I've got a fraction minus another fraction, like up here in the original problem, it's subtracting this whole term. That's why we have to have parentheses here. So I've got 2x minus 2 minus x, because now I'm distributing the negative, and minus 3. So if we didn't have the parentheses, you may mess up and lose that negative sign. All right, minus x squared minus 3x. I'm going to combine my x's first. 2x minus x are on the same side, so it gives me x. And then minus 2 and minus 3 gives me minus 5. Equals, and I've got negative x squared minus 3x. Now I'm going to add x squared to both sides. It's going to cancel this side and move it to the other side. And then I'm going to add 3x to both sides. So x squared, 1 plus 3 is 4x, minus 5 equals 0. Now, you should remember with factoring back in quadratics, this is a quadratic expression, so we should be able to factor this. So we got to solve because it's an equation. So x times x is x squared, what multiplies to give me 5 and adds to give me 4. So I need plus 4 and minus 1. Now these are my factors. So to solve, I have to set this equal to 0. So x minus 1 equals 0 and x plus 5 equals 0. And then I add 1 and get x equals 1.